motor 4 channel. Okay, our member group is first is me, Roberto,
and Atira.
I'm Bintang.
and Nelson. Okay, next the first slide will be Atira will be explained.
Okay, I will explain this project. This project is a 4-channel stepper motor driver. The driver connect the PLC to the motors, and the PLC cannot drive motor because the motors needs high current. Next to the main part.
Okay, this is working principle. Our team is microstepping. Microstepping device one motor step 1.8 into a small substep by controlling the current with both coil using sine and cosine patterns. Second, hybrids, and hybrids is a MOSFET switching circuit that reverse current detection through bipolar stepper motor coil. Next, OCP protection is OCP protect the driver from excess current caused by short circuit, style motor, or component failure. Okay, next. This component selection with RS, we use TMC 2160 plus external MOSFET 30N2 MOSFET. This component verification to RS. Okay, next paragraph.
Okay, I will explain the schematic. The schematic convert 24 volt to 5 volt and 3.3 volt while protect and voltage filtering for the system. And next, the schematic isolate for the step AR and double cycle to protect the microcontroller before sending to the driver. Next to the button.
Okay, so here our main IC, we're using TMC 21608TA. Okay, this for the first channel, the second channel, the third, and the fourth. So for setting our micro stepping and ampere current for the motor, we're using a tiny 1614S for the microcontroller to upload for the TMC. On the right side, every channel, it's the hybrid bridge MOSFET for the motor, which is high and low side, and on the right on the top is for the motor output. Okay, so here the OCP. Okay, so from the first. Okay, on the corner top left is the INA 240A10 is for detecting the current on the VM from the 12-volt port and the current on the IC. On the resistor is for the sense, so the current that move through the resistor will be detected by this component and will be out with label Vsense. It continues to LM393. This is for the comparator, and the first and another pole for the comparison. We make reference voltage is because the LM393 is only can detect the voltage, so we make the voltage reference and will be sent to this component This component is for the latch. Latch is saving the error. If we don't push the switch, it will be still error. The red LED will be still on. And for this is the on IC to disable the driver. Right, the first one fault to the first stage is OCP 1, and the diag one will be fault pre. This will be connected to the one, and all this thing will be the output is driver N channel for the IC, and then this is for the to sending the fault or the error to PLC using PC817, and then there's red and green LED for the to show the user if it's fault or no error at all. Okay, I think that's all.
Okay, this is our mechanical design. We use the cover design is 4 channel to CH1 and CH1, CH2, CH3 and CH4, and this is switch. We use indicator LED and indicator power, and we use clip thin rail, and we use more ventilation to this cover. Okay.
This slide I will explain the support limitation for cover design. First, for the mounting, I use the Polex contact for reference, and the next for the terminal block, I use Polex contact terminal block for reference, and the next running part, I use the Polex contact PE terminal, and for the LED indicator, I use for reference before LED indicator, and the last for the cover material, I use the datasheet aluminum enclosure. Okay.
Okay, I will make the conclusion of our project. So we find a solution for the PLC and motor channel mismatch. The solution is using TMC and external MOSFET, and then the motor noise can damage the PLC. We already use optocoupler to isolate both sides, and then the RS requirement are very strict. We switch from the single chip to the pre-driver design, TMC and external MOSFET, and then multiple drives from 24 volt. We use the BUAP to 24 volt to 5 volt, and LDO to 5 volt and 3 volt. Okay, thank you for your attention. Any question?
Why does each channel need a power signal?
Okay, back to the. Okay, why the channel make a fault? Because the IRS itself tells it needs to send a fault to the PLC back.
Okay, thank you.
Okay, any other question?
Which mechanical design parts are most related to the HRS?
Or this is mechanical from HRS full fed to HRS. This green rail, click green rail, and all is all other is verification to HRS. Okay, thank you.
Thank you. Okay. Okay, I think that's enough from